like how we can work together to make the internet work, right? So I said something out on the internet, it's like I'm basically welcoming traffic to my network, right? And if I'm seeing something on the internet, means I'm basically sending traffic to the network. So we'll talk more about that one. But this is how the general structure of internet would look like. So we basically using ICP gateway protocols within the same monolithic system now to allow the packets to our traffic. And we use basically BCP as the gateway protocol to route packets outside of our network, which several allows this. So if you classify broadly, there are static routing protocols and dynamic routing protocols. So static routing protocol is just like you have to have a manual entry in the routing table of some type, but for the dynamic routing protocols, they can be basically classified as two. That is the internet gateway protocols and external gateway protocols. So for internet gateway protocols, also there are two types of routing protocols. There's distance vector routing protocol and link state routing protocol. So OSPF and ISIS are basically doing the link state routing, and RIP and EIGRP, they do the distance vector routing. So, and another thing is exterior gateway protocol that's basically doing routing outside of the network and keeps using the path vector protocol. Right. So basically BGP works on the path. So we'll talk more about like how the path looks like and how route entry, the BGP table would look like. Right. So yeah, routing works on remote. So whatever a router learns on the internet means like it's sharing the same thing, same information to all routers as well, right? So if I am a neighbor, say for example, if I and you are a neighbor, and whatever I learn, I send it to you, and whatever you learn, you send it to me, right? So basically, there are two kinds of information based actually in the routing routers. So there is a forwarding information based and routing information based. And the routing based information base is actually filled up by the routes received from the BGP routing table, ISIS links to database, connected routes that's within the same router that's connected directly to it, and other static routes as well. Okay, so all the routes from the BGP or the ICP or connected routes or static routes would go into your routing information base, right? But all of the routes that that's been collected on the router is not the best. So whatever is the best path is actually only kept in the forwarding information base, right? So all the best paths would be going into the forwarding information base. So whenever a router receives a packet on one of these interfaces, it actually looks into the forwarding information base and just forwards the packet. That's all a router can do, right? So we need to understand routing basically works in reverse. So basically, if I'm a router on the internet, means like I'm listening to every other network, adjacent network, and whatever I receive from the adjacent network, I will pass it on to my other adjacent networks. So yeah, so IP route lookup. So whenever a router has to do a route lookup, say for example, a particular destination on the internet, particular route, then the thing that we use is basically the longest prefix math. So there is a concept called like more specific prefix is preferred over less specific prefix. So if you have like a slash 22 and a slash 24 for the same route, is slash 24 would be the longest on the prefix. Right? So slash 22 prefix would always slash 24 prefix would always be preferred for one. So as you can see the example, so there are three options for you to get to the GNC office from the airport. There is Hanoi and Vietnam, that's the city name and the country. And there is some street address, again the city name and the country, and again, the street number as well. City name and the country. Which one would you choose?
So WhatsApp ma online message
Number three, right? Because that's the specific one. So that's the same concept actually, right? So /24 is more specific than /22. And the decision to routing also is made on the longest mass route, longest prefix mass. Right? So if we see the same prefix /22 and /34 or two links, then we already refer the link from which we are receiving the /24 instead of the slash.
केवल लूज भाव उता चाहिँ केवल लूज होला
Sorry, let's just fix this screen before we start. Okay, thank you. So yeah, we basically choose number three, right? Because it's the most specific one. This is one thing to keep in mind. Right. So if we take an example here,
प्रेजेन्टरको ल्यापटप चाहिँ केबल खोइ अनि हिजो हामी यहाँबाट यहाँ आउने थियौँ अर्को छैन हिजो नै नभइरहेको थियो यस्तो यो प्रेजेन्टरको ल्यापटप यहाँ जोडेको छैन अब यहाँबाट यहाँ के भनौँ USB से जोड़ा छ है यो USB वालाको टाइप 3 जोडेको छैन एउटा HDMI चाहिँ USB आउट HDMI आउट गर्छ त्यसको साथै पनि गर्छ त्यसको साथै काम गर्ने हो ब्ल्याक म्याजिक पिक्सल भएन यो चाहिँ डिभाइसकै कनेक्सन भयो कि यो चाहिँ ल्यापटपमा जोड्नु पर्छ कि यहाँबाट अनि टिभीमा चाहिँ स्विच गर्ने हो नि त मलाई चाहिँ खुलाएको भने USB र के हुन्छ टाइप सी वालाले नै पनि जान्छ जस्तो लागेको किनभने चाहिँ यही खोज्दैछ नि त हिजो अस्ति कनेक्ट गर्नलाई यो त यो हिजो अर्कै गरेको थिएँ होइन सेटेपछि गर्छ सो किनभने यो रुममा त हामीलाई टेक्स्ट गरेर गयो नि त सुमै गरेर क्यामेरा पनि उ छ सबै मिलाएर
sorry. And thank you. Okay, so when we talk about the IP route lookup, right? So basically there are 1, 2, 3, 4, 5, 6, 7, 6 routers on the internet, right? So every router is belonging to one autonomous system number, right? So the numbers on the top of the router is basically the autonomous system numbers, right? So whenever you're sending a route on the internet, means like you are trying to get the traffic into your network, right? So AS135533 is trying to advertise a prefix 614548.0/42, right? So whenever AS135533 announces that a particular prefix to AS135534, it accepts it and it also advertises it forward to the 135535, right? And gets up to here. Right? So this is my reference point. So when I sit on this router and look at this particular route, I will basically see this is the path, right? So from right, that's your origin AS number, right? And on the left is like your adjacent neighbor. So for me on this router, this is my adjacent neighbor, but I am running this route with the origin AS number of 135533, right? So again, there is another bad guy here, who is basically announcing the same prefix, but with a /24, right? So 135534 is announcing more specific prefix than that one, right? So that's a /24. And if I sit on that router and see that information, I have the prefix and only two paths, two AS number in the path, right? So if you compare these two in terms of path, this has the sort of path, right? And if you compare this in terms of the prefix length, this is a /22 and this is a /24. So we always talked about at the beginning, we talked about like, the shortest path should be always preferred, right? So it would always prefer this particular path. And also you can see that /24 here instead of a /22, even the path would have been the same. Always this particular path would have been chosen, right? So basically, bad guy would be chosen over the right guy, right? Is there any confusion of this, right? Exact questions. I'm trying to answer as much as I can. I have my other colleagues as well who are helping me to address other questions over online as well. So if you have any questions on online, you can also ask them in the chat, and my colleague can assist you with any other answers to your questions. Thank you. Okay, so actually the next slide actually shows like I'm announcing a /24. /24 from both origin AS number. Right, but still this is the preferred path because it's sort of in length, even though the prefix length are the same, right? So there are two things. One is the length of the path, and another is the
Drop it here on the.
maximum length of the prefix, right? So whatever length of prefixes you are announcing, it all depends, like whether you are announcing a less specific prefix or a more specific. Yeah, so that's hijacking XLT. Actually, right? So basically this guy over here, 135540 is actually hijacking the prefix, right? Because it's telling that, okay, hey, I'm the shortest path, this particular destination, right? So what is BCP hijacking? It's actually announcing a more specific path, right? Just like here. And also announce an IP address space that's owned by some other network on the internet, right? Say, for example, I have a AS number, AS135540, and I have a set of prefix associated with that particular AS number, and I'm only the rightful owner of that particular set of prefixes as well as the AS number, right? If someone else on the internet advertises my prefix, means that's a hijack, right? And there are ways to prevent it. Actually, that's what we are going to talk about more next set of slides. But these are the two things like you can do a BGP hijack. And we are trying. Our goal here today is to try and see like how we can prevent this kind of mechanism in our own network. So yeah, just a few stats. If you see back in 2019, if you compare leaks versus hijack, there are actually more leaks than hijacks, right? And that's one of the facts I would, one of the reasons I would say is basically, uh, uh, there are less networks who are doing filtering, right? And there are more cases of leaks in the past in 2019. I mean, like this RPKI and filtering all became very popular during 2020, 21, I guess, right? So this was the time during the coronavirus started and the world was stuck. Every one of us was stuck inside our homes, and we saw a lot of events actually in that year, right? And one of the reasons is basically the people were not well, network operators were not much educated about the RPKI, even though they are educated. There was no more, not many, I mean, implementation of the RPKI protocol stuff, right? So that's the reason we see like more leaks in there in 2019. So if we compare in 2022, we actually see more hijacks and less leaks because people have started using IR filters, they're doing RPKI, and there is a less number of leaks, and there is more hijacks. Right? So if you see in 2023, so there were around like 145 events, and all of this is actually you can see in the link down below there. If you download the slides, if you look at the slides, you can follow the links and have a closer look at the stats and also read more about like what happened on this kind of events. And I'll be talking about a little few other events here, but not cover all of them. So yeah, actually we have a demo that I can show you on BGP hijack. So it's actually the same thing that we did in the previous slide. Like there was an AS number announcing someone else's prefix and doing that hijack, right? So before we do the demo hijack, I would like to slightly introduce you to our academy. So SCTP academy.fd.net is our academic academy where you can use online tutorials. You can do your virtual labs. But for you to be able to use the labs, you actually need to be a registered user in that system, right? So I'll just show you around and maybe you can get going because this is something that you'll need also in the later part of this session because you need to access resources on Epinic Academy in order to be able to do your labs for this session, right? So let me just go quickly and show you how it's done on how you can access the lab, and also I'll show you a quick demo on BGP hijack. Everything that you'll see that there are different menus here over here, and on the courses you can see the online courses that you can do self-paced. Then there are also some virtual labs that you can do, right? So in order to test a few things, and this is one of the things that we'll be doing, right? But for you to be able to use these resources here, you should be able to register as a user in the system, right? So I already am a user here, so I don't need to be registered, but if you don't have an account, then you should go here and register. So I think let's do this right now so that every one of us has the user and you can just go through the labs uh, and be familiar with this interface, right? And how you can use this virtual lab on the academic. Yes. If you have any questions like how you are trying to access the academic academy, my colleagues over here can help you explain, right? So you can just raise your hand and call us to your location, and then we'll be there to help you out, right? But I think it's a good idea for us to all be a user on this system before we continue ahead, right? So that you also will be able to look at like what are the different kinds of labs or other kind of resources that we have in there, right? But anyway, we'll be using 2 or 3 virtual labs on that academy itself for a part of our tutorial. So please make sure that you have an account on that academy.
स्क्यान गरेर पछाडि फाइनल ल्यापटपमा कसरी जोड्नु
Ethernet हो
इथरनेट जोडेर वाइफाई
यो हो नि के म स्क्यान गरेर मेरो छ के
सेमिनार सेसन त्यही चाहिँ हो त something like that.
So
Join vào đó. Con lại suy coi là phải tiếp những con kiện sẽ rồi sẽ suy phần nào nữa.
Still using me, you have to switch back and
Cái thôi
it was a different time. You can say it to different.
khi mà lên đi làm lại có thể làm một cái bài này. Mình có thể học sinh thứ bài này. Một số bài làm mình có thể cái luôn.
so I think most of you are able to create a username for yourself in that academy, right? So the reason that we waited for a few minutes for everyone to create a user is like we need this in the later part of this tutorial, right? So we're going to use a few virtual labs from the same academic link, and we'll be building RPKI validators and performing some roles and validations, right? So I was talking about demo on BZB hierarchy, right? So basically, this is the kind of topology I have over here in one of my virtual labs, right? And there are five, 1, 2, 3, 4, 5, 6 routers here, and every router has its own autonomous system number, right? And so basically, router one is trying to advertise its loopback address to all the networks on the internet. So every router on this diagram over here is basically trying to advertise one route to its neighbor, right? So if router 6 has to get to router 1, then it has to come through router 5, router 3, and router 1, right? And okay, this is the bad guy here, router 4. If router 4 announces the same prefix from router 1 prefix over here, then the shortest path would be like, if router 6 has to get to the same IP address over here, and it has to go through router 5, 3, 4. And that's what we are going to show. Right, so let me just go into the lab and show you So. Yeah, I think everyone has it there. You can just go to the courses here on virtual labs. Right, so I can see so many virtual labs. So actually, I was doing this lab yesterday. So that we don't take a lot of time here today. We'll just continue on this lab. So please make sure your browser has a pop enabled. Otherwise, it won't. You'll not be able to run this window for the lab. Take a few what? You can hit the lab. त्यो एउटा बोल्ने चाहिन्छ होला के हो लाउने
अन्त भइसकेको छ हजुरलाई त्यो कानमा राख्छ हामीलाई
त्यति पछाडि
त्यसरी हजुर यसलाई कम गर्नुहोस्
भइसक्यो
हजुर ठिकै छ
I'm just going to show a demo on this behavior, but we'll use this virtual lab. Like there are other labs that start to optimize the device. Okay. So actually, you don't need to go into that lab. Right, so I'm just showing it for demo on BGP hijack.
यही रिक्स छ नि एकदम भइहाल्छ यस्तो रिस्की
So whenever you are logged to a lab, you basically see on the right hand side, you can see the instruction and resources for every other lab. Right, so this lab doesn't really have any instruction set. Right, but you have a set of resources that you can use for this lab.
त यहाँबाट
अर्को माइक अफ गर्नु होइन
माइक अफ गरिदिनु
त्यसको नाम चाहिँ के हो डिभाइसको नाम
इनमाइको
दिनमै
हजुर
Okay, so there are a set of resources here, right? So we saw in the diagram earlier. We have 6 routers. Right, so R1, R2, R3, and they have set up in the same proposal. So
This makes you.
basically, if I go to R1 and you see over here, we have R1, R2, R3, R4, R5, R6. So all of these have been already configured, right? So the point-to-point interfaces, the loopback interfaces have already been configured. Even the BGP configuration has already been done. right? So because since this is not the lab that we are actually going to follow, this is just a demo. I actually configured it all already, right? So I'm just going to say like what's in router one. If I go to router one, so if I see my BGP neighbor, right? So router one has two BGP neighbors, right? So as you can see, R2 and R3, right, for router one. So if I show the BGP configuration, so router one has is advertising a network of 1.1.0.0/22. So 255.255.255.0, right? So if I go to router 3 and look like what I'm getting from router 1, so I'm seeing like 1.1.0.0/22 from router 1. Similarly, for other routers also, they are advertising their own prefixes, but all of these are like /32 prefixes, right? So this is what the router 3 sees. And if we go into router 6, so router 6 is actually further away from router 1, right? So if I see on router 6, so yeah, it's also seeing the same route, right? So 1.1.0.0/22 is coming from a next hop address of 172.16.0.9. That is the IP address of this link, router 5 over here, right? And if you see the path here, so you can see like it originates from router 1. Power evada milan bari. So if you see from router 1, router 6, the prefix to router 1, you can see like the path itself here, right? So it just crossing through if you look into the diagram here, so if router 6 has to go through router 1, then it has to go through router 5, router 3, and router 1, right? So there has to be like 3 AS number in the path, right? So this is what we see. 1, 2, 3, right? Now what I'm going to do on router 4 is like basically I'm going to announce a more specific prefix, right? Because that's what we learned earlier. So if you're announcing a more specific prefix, here we see that router 1 is advertising a /22 network, right? So what I'm going to do here on router 4 is like I'm just going to actually let me show you a trace route before we already
41, 41, never. And so I mean the but I think that's not my problem. Sorry, that's not my problem. Okay, so I have some issues on my machine here. And so let me fix this before I show you something more on the demo. 언제 오는 거야? So what I'm going to do is like I'm now going to router 6, right? And actually going to perform a trace route so that I can see that what trace route one is the IP address of the loop back of router 1, right? And I'm doing a source from my look back on router 6. Right, so we're going to yeah. Okay, so okay, so we have like 3 IP addresses in this trace route, right? Those are the hops. And if you look at the diagram itself, we see like 172.160.9 is the interface. This interface for R5 and 171.10.10.10.10 is this interface for R3, right? And 10.10.10.1 is this interface for R1. So basically the path is following it, this path, right? So from R6 it's going to R5, R3, and R1, right? So now what we're trying to do is like this is demo. I'll announce a same prefix but with shorter length, right? So at this time we are doing a /22 where R1 is announcing a /22, but from R4 and I'm going to announce a /24. Means R4 is basically hijacking R1's prefix, right? What? Okay, so on R4, you just go to R4 here. Right, so if I look at my configuration here in BGP, so R4 has one neighbor, that's R3. Right, so what the other one? What? Okay, so R4 has one neighbor, that's R3 in the diagram, right? So R4 is going to announce a /24 1.1.0/24 to R3, and let's see like if the hijack works. Right, so for R4, actually, I need to create another interface so that I can perform a trace route. I'm just creating another interface, and IP address is 1.1.1 1.255.255. .0. Right, so now I'm going to go to BGP, router BGP 135536. Okay, I'm just going to my address family. Okay, so address family IPv4 unicast. So what I'm doing is like I'm basically 1.1.1.0 max 5.5, right? So now if I see, so IPVGP summary, so BGP neighbor 172.16 0.5. Advertised. Right, so now I'm announcing 1.1.0/24 from R4. Now, if I go to R6, then the path that is going to be preferred would be like from R5, R3, and R4. Right, that's what I'm going to show you. Right, so let me go again to R6. Now, if I look in R6, I should be seeing two routes, right? So 1.1.0.0/22 and 1.1.0/24, right? But if you look at the path, they're different, right? Oh no, the path is also the same, right? Because this is the main holder of the prefix, right? So now if I go, right? So now it is different. You can see now it's going from R3 to R4. From if you see in this diagram here, the IP address was 10.10.10 earlier in the earlier case, but now since I am announcing a more specific prefix over here, it's always going to be preferring this path, right? So basically we are doing a hijack from R4 and we are hijacking R1's route, right? So if you go in the diagram here, you can see like now the path it is following is from R5, R3 and R4, right? So instead of going here, it's going here because we are announcing a more specific prefix from this router, right? So this is just I wanted to show you as a demo. Like this is one of the things that you could easily do if there were no filtering in place. Like you could just hijack someone, just grab someone prefix and announce it over the internet, and it would just get hijacked. But in the past days, but nowadays many networks are actually doing a lot of filtering on their AS routers so that this kind of mishaps don't really happen. But still, there are cases of this kind of hijacks being taken, right? So we're basically trying to minimize this kind of incidents using this kind of using RPKI technology, right? So this is one of the objectives of our tutorial here today, so that you be more comfortable on using the RPKI tool itself, right? So that you can have filtering in your AS networks, so that whatever you receive over the internet, you're just filtering it before you put them into your routing table. All right. So if anyone has any questions about this demo, you can just ask me during the breaks, right? Or we can have a look at it together if you're not clear about this one, but I won't take much time because we have other things to cover for this tutorial. Right. So yeah, that was just a demo on BGP hijack. I hope now you get a understanding of like how BGP hijack can take place. You can just take someone else's prefix and announce it over the internet. And if you do not have a proper ROA for it, and if the network on the other side is not doing any kind of filtering, means like you get that route propagated over the internet, right? So it's very easy to do that hijacking actually. But if we have all kind of things in place, means we are just preventing it, right? So yeah, a few examples in the past. Okay, so yeah, this is from Jeff Houston and Randy Bush, right? So yes, there is 12839 that is basically leaking prefixes in Apple's prefixes, right? So actually, you know, just before I say this, there are two kind of things that have usually happen whenever we see this incident of routing incidents like on the internet, right? So basically, it's one of the things is like basically you have your bad intention, right? You're trying to get something out of it. You're trying to hamper someone else's service on the internet. Means you have a bad intention. You're a malicious actor on the internet, and you do these kind of things. But other is like unintentional, right? Sometimes it just happened like because of a configuration error, or you just mistype something on the when announcing or advertising a route. Means it's basically human error, right? It's not a bad intention, but it's just misconfiguration that can also lead to this kind of incident, right? So here you can see that this is actually a similar kind of incident. It's not a malicious intent. It's actually a misconfiguration, right? So Rose Telecom actually has this prefix like 217.70.96.0/19, right? And due to a misconfiguration, right? So they missed the 2 out here, right? So they announced this one. Right. So, and this is like a /8 block from Apple's prefix. So basically, now it's basically announcing a less specific prefix to the internet from Rose Telecom, means it's basically hijacking Apple's prefixes, right? Right. So other cases, there is AS5540, right? So this is a Vodafone Idea that happened in 16 April in 2021, and one of the reasons was like why this got propagated was like they did not have route object, right? And around of the 30K prefixes, only 4,000 prefixes had their RUAs, right? So even if the upstream provider were to be filtering these routes, maybe they would only filter 4,000 routes out of the 30,000 prefixes, right? So one of the many upstream provider is 9498, that's part B, and 1273, that's the Vodafone Global. And spread mostly through IX Internet Exchange Point connection, and also repropagated by 6939, that's Hurricane Electric. So this is also by mistake. Okay? So this is mistakenly they announced prefix, and they basically 30,000 prefixes they're announcing on the internet, means they're all taking all the traffic into their network, right? So that's a lot of traffic. And yeah, there is also hijack on bigger services, large service providers, large content providers like Twitter, right? So when there was an order from the Myanmar military government on board blocking Twitter and Instagram, so they originated one of the prefixes mistakenly. So this is also not with a bad intent, but it's mistaken, right? So one of the good things is like only 6 upstream providers accepted those prefixes, and others were doing filtering based on IRR, means like it's a good thing, like there is some kind of adoption that has already been in place. And you know, like it's a good thing to do filtering for all the announcement you receive from your neighbors, right? But one of the things is like, why didn't Twitter also create a ROA for this prefix, right? So Twitter is one of those organizations which has a long-standing background in the network industry for a long time, right? But still, they're missing out the ROAs for the prefix. So this can happen to anyone, right? And things that is done mistakenly can also affect your services, like even the large ones, like Twitter, right? Who is globally distributed, right? So it's on everybody's part. I mean, like everybody has to do the good thing for us to achieve a proper and a secure routing system. That's one of the takeaways from this slide. Right. So also again, there is another more headlines that is in 2020. I think that's one of the times where this filtering was much popular, and most of the networks started doing filtering on their side. Right. So it hijacked around like 500 more specific prefixes, and that's also not with a bad intent. It's basically an incorrect configuration of the border router. Right. And there is nothing we can do. I mean, like it's a mistake, and it can affect your services at least for a few hours until you find out like what's wrong, right? And yeah, so it just affected the services like Proton Mail for like 3 hours, right? And again, it's not a bad intent. And there used to be cases with optimizers, so BGP optimizers. So what they would generally do is like they would take a prefix, less specific prefix, and break down into like more specific prefix and completely fabricate the path, right? So there is a Tulip system that hijack more than 200 specific prefix, mostly the North American AS numbers, and the hijack lasted for like more than 2 hours, right? And again, there is C, like 1299, that's Telia, one of the largest provider on the internet, right? So they are tier 1 carriers, and they actually propagated those routes, and like amplify amount of hijack on the internet, right? So basically they have to reach out to everywhere, Telia, because they are one of the largest provider on the internet, right? So yeah, one of the things is like even large providers were not doing filtering and route origin validation at that time. So this is 2020 actually. So that, I mean, like that was just the beginning of most of the large networks doing validation and filtering, all sort of things, right? So right after the coronavirus. Again, in 2020, Rose Telecom hijacks around 8,000 prefixes, and most of the major service providers like Facebook, Cloudflare, AWS, Akamai, Google were affected, right? And again, you can see the names there. Some large providers, Rascom is one of the largest provider in Russia, and Cozen Communication is tier 1, even level 3 is tier 1. So most of these big networks, they're actually participating in this route propagation process. So means like if big networks are participating, means like the amount of impact is also big. Right, so you can actually go through this link and have a detailed read about like what actually is the problem, right? I just did not explain a lot of things about it, but just to sit as an example here before I move on to the other set of slides talking about RPKI. Right, so again, BGP optimizers, as I said, BGP optimizers, they basically take a set of prefix, less specific prefix, and break it down into more specific prefix, and also insert that AS number in the path, right? So basically that would be a completely different path than what we had expected. And yeah, again, Cloudflare was affected, and around 15% of the traffic was not available for around 2 hours. So I mean, like for a company like Cloudflare, 2 hours of service unavailability means like it's a long time and a lot of loss in their business, right? So these are the things that can happen. So this is also not a bad intent, okay? So this is some software running into your network, doing some kind of trying to do some kind of a load balancing, but it failed to follow the protocols of the routing integrity, right? So it's basically like you have a /20, Cloudflare is advertising a /20, and you're propagating over level 33356. And again, there is a 33154, which is actually the network that's affecting that route, right? So it's basically breaking down as /20 into /2/21, right? And inserting the path, inserting its ES number into the path, right? So basically, again, there is 701 Verizon, which is one of the largest provider in North American region, right? And it's basically propagating over the internet, right? So you can see that even this has been fabricated here, still the big provider is accepting it, right? So yeah, the following is targeted at a context where a BGP optimizer generates a BGP announcement. Ordinarily not seen in the default free zone. The OP indicated they announced a /23 and were unpleasantly surprised to see two unauthorized announcements for /24 more specific pop up in their alerting system, right? So no permission was granted, means like there was no ROA in the IR system, right? So basically that was the problem. And even if this network would have done the filtering, then the amount of impact would have been much less, right? Again, so there is Google prefix leak, and this is actually a network in Africa, right? So main one is one of the largest provider in African region. So they actually mistakenly announced some of the Google prefixes, right? So this is also not with a bad intent. This is also just a misconfiguration, and this affected actually the last service provider like Google, and most of the Google services were not available for around like 74 minutes, right? So basically the thing is like AS3377282 main one, which is one of the largest provider in African region. They link it to China Telecom at IXPN, that's in Lagos in Nigeria, that's the internet exchange point of Nigeria. And they linked it over the IX and will link it over to again to their peers in upstreams, right? So Trans Telecom is also one of these large providers. So this was basically an error due to a planned network upgrade due to a misconfiguration on the BGP filter, right? So it's basically a misconfiguration, but still affecting a lot of other providers, right? So one of the things you can think of right now is like, even if you're doing a misconfiguration on a site, can actually affect other providers on the internet, right? So, I mean, like, we all have to be good actors, right? We all have to do the right thing. That's what it says. And yes, again, a few examples on like bad intents. So whatever I was talking about was like misconfiguration. Those are the kind of human errors that basically happens, and they can be rarely prevented, right? But I mean, like, human errors can happen at any time, but it's always good to have things in place, right? So that you can prevent the effect that comes out of that human error, right? And as an example, again, you might also already know there is a hijack on the Amazon DNS Route 53 prefixes, right? So basically, there was more specific /24s were announced of this /21 network, right? And the originator was 10279, that's init, and it actually peers with other large providers, which shared that more specific announcement to other peers on the internet. Right, so again, you see the motive here is bad intent. You're basically trying to steal someone else's money on the internet, right? So during the period, the DNS server in the hijack range only responded to myetherwallet.com. So I think all of you remember this incident from Amazon, right? So all the DNS queries coming to those IP addresses /24s were actually responding to myetherwallet.com, and basically it was the fake DNS, fake servers that got that sent the answers, DNS server, right? And they redirected it all to my Ether wallet, stealing the credentials for the users, right? So as an example, you see like you see on the attacker side, on the right hand side, that's a totally real DNS server, right? Because it is within the same IP address range, just the BGP thing, right? Because BGP always look into the source path, but the IP address is the same of the resolver, right? And yeah, so whenever an attacker has to query that DNS server from that totally real DNS server, it actually send a response to like myetherwallet.com, and the users just gave away the usernames and passwords so that the attacker could steal their money out of it, right? So yeah, resolver querying any Route 53 object managed name would ask the authoritative servers controlled through the BGP hijack, right? So yeah, one of the things is like BGP is on one hand, but DNS is other thing, right? So DNS is application, BGP is something that's related to the network, right? The DNS has not changed there, but things have changed slightly on the BGP, and that's creating the problems, right? Again, there is examples, more examples. 2017, Google leaked around like 130,000 prefixes. That was a long time back, actually. And there was around 25,000 were NTT OCN's prefixes. That is one of the big providers in Japan, right? And this was again advertised to other providers like KDDI and IIJ, Internet Initiative Japan, who accepted it and propagated it further, right? So everyone who received the link more specifically for like Verizon Google part. So basically, this is the kind of thing like before the hijack, it was from Tokyo to Osaka. I mean, like from source to the destination, it was within Japan, and the time is like 22 milliseconds. So that's a normal time, right? But once the leak happened, then you see like you go going to Tokyo to San Jose in the US, and again returning back to the same destination through across the region, right? So and you can see like the latency has increased by 10 times. So means the services are being affected. Right. And if you look at into EU to EU, again, it's the same thing. The services have the latency has increased significantly, like over 10 times. Right. So there are two things we always consider on the internet. Like we need to have that service fast. We need to have that service reliable. There's two things, right? So here it's affecting the latency, means like the service is quite slow. Yeah, and again, back in 2008, I think everyone remembers this one. So around 2 hours, Pakistan Telecommunication Limited, they actually announced a /24 out of YouTube so prefixes, and it was further propagated by 3491 PCCW. That's one of the transit providers in the region. And yeah, again, it actually impacted YouTube for around like 2 hours. And it's one of the first incidents, I guess, that happened, and we all realize the importance of having this kind of technology implemented into our networks, right? And yeah, actually, there are a lot of examples that you can read out. We actually share a few links on the slide as well, where you can